Okay, let's look at an example of this rule of 72 and compounding interest, and then I'll walk you through the assignment that you have on the rule of 72 for today. So first, let's talk about this example. It says, assume you're 17 years old, which a lot of you are, or close enough. You inherit a measly sum of $5,000, which I certainly couldn't retire on, but I know I can invest and hopefully start to build some wealth and be able to retire. So it's placed into a mutual fund averaging 12% interest per year. It says that is a great unusual mutual fund because mutual funds usually return 6, 7, 8, 9% interest per year. So this is a bit aggressive, but it's trying to illustrate the point. It says, how much money would you have at age 65 if you did nothing? Meaning you've left the money alone, you put the $5,000 in and just let the interest compound. So there are financial calculators that can help you figure this number out pretty precisely, or we can use this rule of 72 as a general approximation to do it. So let's go that route because we're lazy and it's easier. So the rule of 72 says that I'm going to take 72 divided by the interest rate to figure out how long it would take to get this $5,000 to double. So if I take 72 divided by 12, I'm going to get 6, which means every 6 years it's going to double. So that 5,000 will become 10,000 in 6 years. Okay? But we're wondering at age 65 how much it's grown to. So what do we need to do? Here's the calculation showing every 6 years. What we need to do next then is say how many years from now when I'm 17 until I'm 65, and there's 48 more years for you guys to invest and grow money. Which means if you have 48 years and it's doubling every 6, it's going to double 8 more times in your life until you turn 65. 8 doubles. So then you just kind of go through the 5,000 becomes 10,000 is 1 double, 10 becomes 20 is 2 doubles, 20 becomes 40, that's 3 doubles, 40 becomes 80, that's 4 doubles, 80 becomes 160, that's 5 doubles, 160 becomes 320, that's 6 doubles, 320 becomes 640, that's 7 doubles, and then 640 becomes $1,280,000. That's the 8th double in your lifetime. So that mere $5,000, if you get it in an investment that's returning 12% between the ages of 17 and 65 for those 48 years, it's going to grow to $1,280,000. So that is the example of why and the power of compound interest. Make sure you do that. So let's look at our homework problem for today, which is the rule of 72 assignment. It's listed next in Canvas and it says to show all your work. And it's talking about the rule of 72 is all about doubling your investment or your debt if it's debt instead. So what we just did was this one. We took 72 divided by the interest rate to get the number of years it takes to double. Alternatively, or algebraically, if I switch that around, I can do 72 divided by the number of years to figure out what interest rate I would need in whatever investment that I chose if I needed money to double in, say, 12 years, or I need money to double in 6 years or 4 years. What interest rate would I have to get on that investment? So you can solve either way. So you're given in this 8 different problems. Okay? And if you notice, number 5 and number 8 are worth 3 points because it's going to be more detailed calculating it and showing all your doublings like we did in the example. So pay attention to what it's asking for in each of these questions to figure out which one of these that you're using. but what I know is 72 always in the numerator. So it says, what annual interest rate will cause your money to double in 4 years? So I know 72, and I know the number of years is 4. I'm asking for the interest rate, so I use this one. Then it says Steve's invested $500 for college. What rate of return must he earn for his investment to double in 6 years? So again, I know 72 and I know 6 years. It's asking for interest rate. Debbie owes $2,000 on a credit card that charges her an annual percentage rate of 18%. If she stopped making payments, how long would it be before the balance on her credit card reached $4,000? Okay, so again, I know that it's a rate of 18%, so 72 divided by 18 is my number of years before I know how long it took for her balance to go from 2,000 to 4,000 to double. And then it's going to go through some different scenarios. So if you have questions as you start to go through this, let me know, but you may have to show the doubling calculation like we did in that example, or you may just have to show the 72 divided by some number to get an answer. But show all of your work and then circle your final answer so I know what your answer is, if it's a rate, if it's years, if it's dollars, or whatever. That's it.